So we're doing the topic of complex numbers, but it's written in many different forms, ranging from Cartesian, which looks like this, to polar or rectangular form, and Euler's form. And it can be a little bit confusing. So let's start off with an example. Let's say root 3 minus I. Okay, so what does that actually look like? Well, if we draw it on a Argand diagram, then there's our real section here, there's our imaginary section, and this here, when we draw the dot, there we go, finally done. Well, then it would be minus root 3 for the real part, so we come across here to minus root 3, and it would come down here to minus 1. And therefore we can see that that would be in the Cartesian form for z. But what about if we wanted it in polar form? Well, in polar form we need to know its magnitude. How do we find the magnitude of z? Well, we can cut it up. We're actually after its length, so that would be Pythagoras' theorem, so it would be the square root of minus square root of 3 squared. In fact, we don't need the minus because it's actually only talking about its length, not its direction, plus 1 squared. And that will give us the square root of 4, which is 2. So therefore, that is the magnitude of z equals 2. Alright, and the angle? Well, the angle we actually want, don't forget, is always from the horizontal positive, the real positive, either going this way round to 180 or pi in radians, or going in a negative direction. So we know this angle we're after, this theta, is greater than minus pi and less than or equal to pi. Or if you wanted to think of it another way, minus 180 degrees and 180 degrees. So how do we work out the angle? Well, again, let's work out this angle first. So what we're actually after is this for theta. So if we work out this angle instead for now, so this distance down here, this distance here is 1, this distance here is square root of 3. So this angle, well, we can use tan for that, and therefore that angle of the triangle would be inverse tan of 1 over its adjacent, which is root 3, and that will give us 30 degrees, and we should know that that's a sixth of pi in radians. So therefore our theta that we actually want, well, theta would therefore be, in fact it's in a negative direction, so our theta would be negative 5 pi on 6 radians, or if you want to see it in degrees, it would be negative 150 degrees, because we're coming from the 0 going in a negative direction all the way around, almost to pi, but just a little bit short. So in polar form, our answer to the same question would be 2 for the magnitude, cis, and its angle, which we'll leave it in radians, 5 pi on 6. And notice that, remember, that if we needed to expand that out to use it in any form, it'd be, oops, don't know why I put the minus there. Let's get rid of that. It would be 2 cos of that angle plus I sine of the same angle. So if you had to type it into your calculator, or you do some calculations with it, and we can see that that's why these rules have come about. If you think about expanding these and looking at these rules, we can see that. And there's that one, and therefore if it's in Euler form, well, it's the same magnitude, which would be 2e to that same angle, and we'll leave it in radians, minus 5 pi on 6 I. So I hope that helped. Thanks for watching, and I hope to see you again soon.